Students, welcome to Sunil's tutorial. I'm Sunil Mirwani and today we'll be doing this chapter called as inverse circular function. Let's see this, guys. Find sine inverse of root 3 by 2. Right? Now guys, all you have to do is when you're doing inverse circular function, you have to remember the format that if sine A is equal to B, then A is equal to sine inverse of B. That means if I take sine from one side to the other side, it becomes inverse, right? So let's see how do we solve this out. You will say let sine inverse of root 3 by 2 equal to x. Therefore, if I use that formula, I'll get root 3 by 2 is equal to sine x. But we know that sine 60 is root 3 by 2. Therefore, I can say x is equal to 60 degree. 60 is nothing but 180 divided by 3. 180 is nothing but pi upon 3. 180 is written as pi radians. Therefore, I can say that sine inverse of root 3 by 2 is nothing but pi radians divided by 3. Next, let's see another sum, guys. Cos inverse of negative root 3 by 2. Same way like we did the previous sum, guys. We'll say let cos inverse of negative root 3 by 2 be equal to x. Therefore, negative root 3 by 2 is cos x. Now we know that, but cos 30 is root 3 by 2. But here we have the answer as negative. Now if you remember your coordinate system, all silver teacups, allied angles, right? Cos ratio is negative in the second quadrant and third quadrant. I want a negative answer. Cos ratio is negative in the second and the third quadrant. Second quadrant, this is 0, 90, 180, 270, 360. Reading anti-clockwise. Cos ratio is negative in the second and the third quadrant. If I want a negative answer, that means either it should be in the second quadrant or third quadrant. So I can therefore say that x, second quadrant starts from 90 degree. Second quadrant starts from 90 degree, or third quadrant starts from 180 degree. We said that cos 30 is root 3 by 2, so this is 90 plus 30 or 180 plus 30. So 120 degree or 210 degrees. Right? Do we understand this? See, if you get a negative answer, you have to first find out the quadrants in which the given value will be negative. If it is negative in the second and the third quadrant, write the starting point of those quadrants plus the angle. Right? So in that case, therefore I can say that cos inverse of negative root 3 by 2 is 120 degree or 210 degrees. Next, let's see another sum, guys. Tan inverse of negative 1. We'll say let tan inverse of negative 1 be x. Therefore, x is equal to, negative 1 is equal to tan x. Right? Again, I have a negative value. Negative value means I need to use allied angles. All silver teacups. Right? Now, tan ratio is negative in the second quadrant and the fourth quadrant. Second quadrant starts from 90 degree. Fourth quadrant starts from 270 degree. Right? Now we know that tan 45 is 1. So you will say 90 plus 45 or 270 plus 45. So this is going to be nothing but 135 degrees, or this is going to be 315 degrees. Therefore I can say that tan inverse of negative 1 is 135 degrees or 315 degrees. That's how you find these values. Next, now let's see if we have multiple functions, how do we solve them? These These were simple functions. Fourth, find the value of cos inverse of cos 13 pi by 6. Right? Same method, let cos inverse of cos 13 pi by 6 be equal to x. So if I take cos inverse on the other side, it will become cos, so you will get cos 13 pi by 6 is equal to cos x. Use allied angles. Now if I use allied angle cos 13 pi by 6, I need to reduce this. Before I cancel the cos function, you have to reduce the given angle into simplest form. What do I mean by reducing the angle to the simplest form? I need to reduce the angle to a value less than 360 degree. Now, cos 13 pi by 6 can be written as cos 2 pi plus pi by 6. Cos 13 pi by 6. See guys, 6 2s are 12 plus 1 13. So 13 pi by 6 can be written as 2 pi plus pi by 6. Question. So how do we know that how we will reduce it? For reducing a given angle, there are only 4 methods you can use. Those are either you have to add subtract with pi by 2, pi, 3 pi by 2 or 2 pi. Whatever is the given angle, add subtract something to this to get the given angle. Like in this case, I used 2 pi plus theta. Right? Now cos 2 pi plus theta, we need to use allied angles. 2 pi plus theta first quadrant. In first quadrant, all trigo ratios are positive. Right? For pi and 2 pi, the trigo ratio does not change. Guys, we've done this in allied angles. So this will be cos pi by 6 is equal to cos x. Therefore, cos gets cancelled. X is equal to pi by 6. Fine. Let's see another sum of this kind, people. Tan inverse of tan 9 pi by 8. Same method. Let tan inverse of tan 9 pi by 8 equal to x. Therefore, I can say that tan 9 pi by 8 is equal to tan x. Reduce the given angle into its simplest form. 9 pi by 8 can be written as tan pi plus pi by 8. 8 pi plus pi will give you 9 pi is tan x. Tan pi plus pi by 8, allied angles. Pi plus pi by 8, third quadrant. Third quadrant tan ratio is positive. For pi and 2 pi, the trigo ratio does not change. So this will be tan pi by 8 is equal to tan x. Therefore, x is equal to pi by 8. Right? You need to remember your basics clearly when you are doing all this. Next, tan inverse of pi by 12 is equal to sine inverse of x. Right? You have to find x. Now, let us assume here you have multiple inverse functions. Let us assume that tan inverse of pi by 12 is equal to theta. Let us assume that tan inverse of pi by 12 is theta. In which case I can therefore say that pi by 12 will be equal to tan theta. Right? If I take the tan function on the other side. Now guys, let's draw a right angle triangle. Let's draw a triangle ABC in which angle B is 90 degree and angle C is theta. So if I am saying that tan theta is 5 by 12, tan is opposite upon adjacent. So this is 5, this is 12. If I apply Pythagoras theorem to this, my hypotenuse will be 13. In which case I can therefore say sin theta will be opposite upon hypo. Question. So why are you finding sin theta? Because look at my answer. I need sin in the answer. That's the reason why I am finding out sin theta. So sin theta is going to be 5 by 13. Take function on the other side. So theta will be equal to sine inverse of 5 by 13. But what is the value of theta? The value of theta is tan inverse of 5 by 12. So I can therefore say that tan inverse of 5 by 12 is sine inverse of 5 by 13. But they have given me that tan inverse of 5 by 12 is sine inverse of x. Therefore, comparing the two equations, I can say that x is equal to 5 by 13. Right? Do we understand how do we do multiple inverse functions? Let's see another sum, guys. Prove that sine inverse of 3 by 5 minus sine inverse of 8 by 17 is cos inverse of 84 by 85. Right? Let's see how do we do this. Let us assume that sine inverse of 3 by 5 is x. Let us assume that sine inverse of 3 by 5 is x. In which case, therefore, I can say that 3 by 5 is equal to sine x. If I take the sine function on the other side, I'll get 3 by 5 is equal to sine x. Draw a right angle triangle in which one angle is 90. So this is, say, if I draw this triangle ABC, one angle is 90 and this angle is, say, x. Sine x is opposite upon hypo. If I apply Pythagoras theorem to this, my adjacent side will be 4. Right? Similarly, I'll say let sine inverse of 8 by 17 be equal to y. So in which case I can therefore say that 8 by 17 is sine y. Draw another right angle triangle, guys. Let's draw a triangle PQR in which Q is 90 degree and R is y. If I'm saying sine, sine means opposite upon hypo. If I apply Pythagoras theorem to this, QR will be 15. Right? Now, I have to find out, look at my right hand side. I want cos inverse. People, imagine, if I take this cos inverse on the other side, it will become cos. This value I have taken as x, this value I have taken as y. So you will say that consider cos of x minus y. Sir, how did you realize that you have to do this? Look at what you have to prove, and from there you have to find out what you have to do. Whatever is the function on the right hand side, take it on the left hand side. The two terms that you have on the left hand side, you've already assumed variables for them. Now cos x minus 5, apply addition formula or compound angle formulas. Cos x minus y will be cos x cos y plus sin x sin y. Right? Cos a minus b cos a cos b plus sin a sin b. Cos x, guys, look at the right angle triangle. Cos x is going to be nothing but 4 by 5. Cos y is going to be nothing but 15 by 17 plus sin x. Sin x we already know is 3 by 5. Sin y is 8 by 17. This is 60 by 85 plus 24 by 85. This is nothing but 84 by 85. So we have found out that cos of x minus y is 84 by 85. We just found this out, people. If I take the cos function on the other side, then I can therefore say that x minus y is cos inverse of 84 by 85. Cos function on the other side, right? Resubstitute the value of x and y. X is nothing but sine inverse of 3 by 5 minus y is nothing but sine inverse of 8 by 17 is cos inverse of 84 by 85. right? I'll show you another sum of this kind. Suppose if they tell you to prove that tan inverse of 1 by 7 plus cos inverse of 4 by 5 is pi by 4. Right? Guys, look at the previous sum and try solving it on your own. Same method has to be used. How do I do this, guys? Let tan inverse of 1 by 7 be equal to x. Therefore, I can say that 1 by 7 will be equal to tan x. Right? Draw a right angle triangle, 90 degree. Let angle C be equal to x. Tan is opposite upon adjacent. 49 plus 150 is 5 root 2. Right? So my hypo is going to be nothing but 5 root 2. Right? Next, let's see this. Let cos inverse of 4 by 5 be equal to y. Therefore, I can say that 4 by 5 is cos y. Draw your right angle triangle. I'm drawing it here only, guys. Let's assume this is triangle PQR, and let's assume that angle y is equal to angle R is equal to y. Now cos is adjacent upon hypo. If I apply Pythagoras theorem, sin PQ will be equal to 3. Now let's see the answer, people. I want tan inverse of 1 by 7 plus cos inverse of 4 by 5 should be equal to pi by 4. That means pi by 4 is nothing but 45, and we know that tan 45 is 1. So what we are going to do is, we are going to find out tan of x plus y. Whenever there is pi by 4, when there is only an angle given, people, it's always the tan function. On the right hand side, if there is no trigo ratio given to you, if there is no function given to you, that means the trigo ratio that has to be taken is tan, because it's only in the tan ratio that you get an answer 1, and that's the reason why the trigo ratio is not written. Okay, so in simple language, all you need to remember is that on my right hand side, if I have only an angle, then you have to take the trigo ratio as tan. Right? Let's apply addition formula to this. Tan A plus B is nothing but tan A plus tan B upon 1 minus tan A tan B. Right? Now, this can be written as tan x. Let's look at that figure. We can find out the value of tan x. Tan x is nothing but 1 by 7 plus tan y. Tan y is going to be 3 by 4 upon 1 minus tan x. Tan x is 1 by 7. Tan y is 3 by 4. This is nothing but 4 plus 21 upon 28. LCM, people, upon 28 minus 3 upon 28. Right? So in that case, this is going to be nothing but 28 gets cancelled. This is 25 upon 25, which is 1. Right? So we just found out that tan x plus y is nothing but 1. 1 can be written as tan 45. We know that the value of tan 45 is 1. Therefore, I could say that tan x plus y is tan 45. Tan and tan gets cancelled. Resubstitute the value, people. Tan, x we've written, assumed as tan inverse of 1 by 7 plus y we've assumed as cos inverse of 4 by 5. 45 can be written as 180 divided by 4. 180 is nothing but pi radians, so this is pi by 4, and this is what we have to do. Right? Next, let's see another sum, people. prove that twice tan inverse of 1 by 8 plus tan inverse of 1 by 7 plus twice tan inverse of 1 by 5 is equal to pi by 4. Right? Now, since all my trigo ratios are same and I have twice tan inverse, I cannot draw the angle here. I cannot take the assumption that twice tan inverse of 1 by 8. So in which case I need to do this by a different method. I need to do this by using inverse formula. Now I'll first give you the formula, guys. Write this formula down. Tan inverse of A plus tan inverse of B is given by the formula tan inverse of A plus B upon 1 minus AB. Okay, so we are going to use this inverse formula. Let's start with the left hand side, people. LHS is twice tan inverse of 1 by 8 plus tan inverse of 1 by 7 plus twice tan inverse of 1 by 5. Twice tan inverse of 1 by 8 can be written as tan inverse of 1 by 8 plus tan inverse of 1 by 8. 2x can be written as x and x plus x. Similarly, this could be written as tan inverse of 1 by 8 plus tan inverse of 1 by 8 plus tan inverse of 1 by 7 plus twice tan inverse of 1 by 5 can be written as tan inverse of 1 by 5 plus tan inverse of 1 by 5. Now, if I use the formula given up, I have written here, that's tan inverse of A plus tan inverse of B. This will be nothing but tan inverse of A plus B upon 1 minus A B. The first bracket I am expanding by using the formula tan inverse of A plus tan inverse of B is tan inverse of A plus B upon 1 minus AB plus tan inverse of 1 by 7 plus, again I am going to use this formula tan inverse of A plus tan inverse of B. Tan inverse of A plus tan inverse of B is tan inverse of A plus B upon 1 minus AB. Right? This can be written as tan inverse of 1 by 8 plus 1 by 8 is 2 by 8. 64 minus 1, 63 by 64 plus tan inverse of 1 by 7 plus tan inverse of 2 by 5 upon 25 minus 1, 24 by 25. Right? LCM, guys. I'm just doing LCM here. Now, let's see the cancellation. 8 ones are 8 8s are. Okay, and here this is going to be 2 ones are, 2 12s are, 5 ones are, 5 5s are. Right? Now, this is going to be tan inverse. Denominator of denominator becomes numerator. So this 8 will be multiplied by 2. So this will be 16 by 63 plus tan inverse of 1 by 7 plus denominator of denominator becomes numerator, tan inverse of 5 by 12. I need to apply the formula again. Now this could be written as let's see this. If I use the first two terms and apply the formula, tan inverse of A plus tan inverse of B is tan inverse of A plus B upon 1 minus A into B plus tan inverse of 5 by 12. Right? Now, this could be further expanded as this is going to be nothing but, when you simplify this, this will be tan inverse of, once I do the LCM and simplify this, This should give me 7 by 17. Tan inverse of 7 by 17. That 16 by 63 plus 1 by 7 upon 1 minus 16 by 63 into 1 by 7 should give me 7 by 17 plus tan inverse of 5 by 12. Use the formula again. Tan inverse of A plus tan inverse of B is nothing but tan inverse of A plus B upon 1 minus A into B. Right? Simplify this again. This will give you tan inverse of 169 upon 169, which is nothing but tan inverse of 1. Right? Now guys, we know that tan 45, guys, see this. Tan 45 is 1, that means 45 has to be tan inverse of 1. 45 is nothing but 180 divided by 4. So tan inverse of 1 can be written as pi by 4, and I presume that's what I had to prove. Fine, do we get this thing clear? Next, let's see another sum, people. Prove that cos inverse of 63 by 65 plus twice tan inverse of 1 by 5 is equal to sine inverse of 3 by 5. Right? Now, I have multiple functions here. I have cos, tan and sine, all of them. So I'll have to make an assumption here to do the sum. So you'll say let cos inverse of 63 by 65 be equal to x. Therefore cos x will be equal to 63 by 65. Now let tan inverse of 1 by 5 be equal to y. Therefore tan y will be equal to 1 by 5. Right? Next, similarly let sine inverse of 3 by 5 be equal to z. Therefore sin z will be equal to 3 by 5. Let's draw the right angle triangle for all of them, people. Let's assume this angle is 90, this is x. Cos is adjacent and hypo, right? So in which case I should get this as I'll just calculate this and give you. In the meantime, just let me draw the other triangle. This is going to be y, this is 90, so tan is opposite upon adjacent. So this is 5 5s are 25 plus 1, 26. So this is going to be root 26, and here if I draw this is going to be z, this is sine 3 and 5, so this is going to be 4. Right? Now what I'm going to do is I'm going to find out a couple of more things. This, when you solve this will come to 5. Okay. Now before I start with the sum, I'm going to find out a couple of more things. Why I'm going to find that out, I'll show you a little later. First let's see how do we find this. I'm going to find out the value of cos 2y. Cos 2y, I can use multiple angles and find this out. Guys, cos 2y is nothing but cos square y minus sin square y. Cos 2y is going to be cos square y minus sin square y. Multiple angle. Cos y, cos is adjacent upon hypo, cos square y minus sin square y. Right? So in that case this is going to be 25 by 26 minus 1 by 26. 24 by 26, which is going to be nothing but 12 by 30. I will also find out sin 2y. So why are you finding this out? Just give me 2 minutes, I'll explain to you why I'm finding out. First let me just find out the values. Sin 2y, multiple angles. Sin 2 theta is 2 sin theta cos theta. Sin 2y is going to be 2 sin y cos y, which is going to be equal to 2 sin y, sin opposite upon hypo, cos adjacent upon hypo. So this is going to be 10 upon 26, which is nothing but 5 upon 13. Right? Now the question, why did I find this out? Look at your sum, guys. I have the sum. If I express it in terms of variable, I need x plus 2y. Cos inverse of 63 by 65 I have assumed as x, plus 2. Tan inverse of 1 by 5 I have assumed as y. Now what did I tell you? Look at your left hand side and bring the right hand side function. On the right hand side I have sine inverse. If I bring the sine inverse on this side, this will become sine. So what I'm going to do is, I'm going to try to find out sine of x plus 2y. Do you understand how I get this? Guys, take the variables from the left hand side, take the function from the right hand side. Take the variables from the left hand side, take the functions from right hand side. This is x, this is y. These are my two variables on the left hand side. The function on the right hand side was sine inverse. When I bring it on the other side, it becomes sine. So I'll say consider sine of x plus 2y. Now sine of x plus 2y, I can expand this by using addition formula. Sine a plus b, sine a cos b plus cos a sine b. Sine x. Sine x is going to be nothing but 5 by 65 into cos 2y. Cos 2y we've already found out as 12 by 13. Cos x. Cos x is going to be 63 by 65. Sin 2y we found out as 5 by 13. Right? Now when I simplify this, this is going to come out to 507 upon 507 into 65 by 13, taking 65 by 13 as common denominator. When you simplify this, this will come to 3 by 5. But 3 by 5, guys, if I look at my right hand angle triangle, I can say 3 by 5 is nothing but sine z. Right? So what have I just proved? I have just proved that sine x plus 2y is sine z. This is what I have just proved. Sine function I can cancel from both the sides. Therefore, I can say that x, what was x? We had assumed x as cos inverse of 63 by 65 plus twice y. Y we've assumed as tan inverse of 1 by 5 is equal to z. Z is sine inverse of 3 by 5. That's how you prove this. Right? Do we get this in here? Next, let's see another sum, guys. Prove that. Awesome. Find tan inverse of cos x. I think I'll do this. Should have sin x. Very important sum. From this chapter, what I'm going to do now is, these are a couple of very important sums. Okay. Now we will have to find the value of tan inverse of cos x upon 1 plus sin x. Now remember, if you have fraction inside your bracket, whatever trigo function you have outside, I have to get the same trigo function inside the bracket. Now inside the bracket I have cos, I have sin, I have everything except tan. I need to get a tan angle. Observe very carefully, guys. Tan inverse. Cos x, I can use submultiple here. Cos x can be written as cos square x by 2 minus sin square x by 2. Cos theta is cos square theta by 2 minus sin square theta by 2. Submultiple. You need to know your trigo formulas very well, right? Now, plus, right? Observe carefully, people. Sin x, I can use multiple formula again here. Sin x can be written as 2 cos x by 2 sin x by 2. Submultiple formula, sin theta is 2 sin theta by 2 cos theta by 2. 1 can be written, please observe carefully, people. 1 can be written as cos square theta plus sin square theta. 1 can be written as cos square x by 2 plus sin square x by 2. Now, this can be written as tan inverse. My numerator is in the form a square minus b square. A square minus b square is a plus b into a minus b. My denominator is in the form a square plus 2ab plus b square. My denominator is in the form a square plus 2ab plus b square, which can be written as a plus b the whole square, right? Cos x by 2 plus sin x by 2 and the square gets cancelled, so this will be tan inverse of cos x by 2 minus sin x by 2 upon cos x by 2 plus sin x by 2. Remember what I told you at the beginning of the sum? Whatever is the trigo function outside, I need to get the same function inside, right? I need tan. Now if you recall all your trigo formulas, whenever you have to get tan, the easiest way to get tan is that the first number of your denominator should be 1. In all tan formulas, the first number of the denominator should be 1. Now if I want to make this number as 1, I will have to divide this by cos x by 2. Guys, understand the logic instead of mugging up. I have a tan inverse outside, I need to get tan inside. For all tan functions in fraction, the first number in the denominator is 1. If I want to make that number as 1, I will say divide numerator and denominator by cos x by 2. So in that case, this will be tan inverse cos x by 2 upon cos x by 2 can be written as 1, right? Sin x by 2 upon cos x by 2 can be written as tan x by 2. Sin upon cos is tan. Cos x by 2 upon cos x by 2 can be written as 1. Sin x by 2 upon cos x by 2 can be written as tan x by 2. I have divided every term in that fraction by cos x by 2. Now please observe carefully. Tan x by 2 can be written as tan x by 2 into 1. Whether I write tan x by 2 or I write tan x by 2 into 1, it's the same thing. Now let's see this. This can be written as tan inverse. 1 can be written as tan 45. Tan 45 is 1. So this can be written as tan pi by 4 minus tan x by 2 upon 1 plus this one I'm substituting as tan pi by 4 into tan x by 2. Right, people? Now this is in the form tan A minus tan B upon 1 plus tan A tan B. This is addition formula, right? Tan A minus tan B upon 1 plus tan A tan B is nothing but tan A minus B. Tan inverse and tan are complementary functions. Tan inverse in reality is nothing but 1 upon tan. So tan inverse and tan are complementary functions, so they will cancel each other. So my answer will be pi by 4 minus x by 2. Right? Let's see a couple of more sums of this kind, people. Find the value of tan inverse of a cos x minus b sin x upon b cos x plus a sin x. Right, people, let's try to understand this. I have a tan inverse function outside, that means I need to get a tan function inside. For all tan functions which are in fraction, the first number in the denominator should be 1. If I want tan, my first number in the denominator should be 1. To convert this number as 1, I need to divide this by b cos x. If I want to convert this number into 1, I need to divide the fraction by b cos x. So I'll say divide numerator and denominator by b cos x. So in that case, this will become tan inverse a cos x upon b cos x will give you a upon b minus b sin x upon b cos x is going to be nothing but sin x upon cos x, which is nothing but tan x. b cos x upon b cos x. b cos x upon b cos x is going to be 1. b cos x upon b cos x is going to give you 1. So this will be 1 plus a sin x upon b cos x will give you a upon b tan x. Right? If I divide the numerator and denominator by b cos x, this is what I'll get. People, see this. This is in the form tan inverse of a minus b upon 1 plus ab. Remember, I had just given you a similar formula some time ago in the previous sum. Tan inverse of a minus tan inverse of b is nothing but tan inverse of a minus b upon 1 plus ab. If I use this formula, this will become tan inverse of a upon b minus tan inverse of tan x. If I use this formula, this will become tan inverse of a upon b minus tan inverse of tan x. Tan inverse and tan gets cancelled, so your answer is going to be tan inverse of a upon b minus x. Next, let's see another sum, guys. Sin inverse of 3x minus 4x cube. Right? Now, let's see this. What we are going to have to do here, guys, is we are going to have to use a family called as triple angle. I don't think I've given you the formulas of triple angle. What I'm going to do is, first thing I'll give you all the formulas of triple angle. Please write these formulas down. Triple angle formulas. Triple angle formulas, there are only 3 formulas here. Triple angle. 1, you have sine 3 theta. As the name suggests, triple angle 3 theta. Sine 3 theta is 3 sine theta minus 4 sine cube theta. Next, cos 3 theta. Cos 3 theta is 4 cos cube theta minus 3 cos theta. Next, tan 3 theta. Tan 3 theta is 3 tan theta minus tan cube theta upon 1 minus 3 tan square theta. These are my 3 triple angle formulas. I don't think I've given you these formulas before. That's the reason I've given you all the formulas now. Now let's see this. Let's try to do this sum. Here they've told you to find the value of sine inverse of 3x minus 4x cube. Right? What you will do is, let's assume let x be equal to sine theta. Let us assume x is sine theta. Why did I make the assumption? Guys, look at this. The function I have outside is inverse, sine inverse. I have a sine function outside. To solve this, I need to have a sine function inside. So I'll therefore say this is equal to sine inverse of 3 x I'm substituting as sine theta minus 4 sine cube theta. This is sine inverse of 3 sine theta minus 4 sine cube theta. If I use the triple angle, this is nothing but sine 3 theta. Sine inverse and sine gets cancelled, so this will be 3 theta. Now, as x is equal to sine theta, if I take the sine on the other side, I'll get sine inverse of x will be equal to theta. If I take sine on the other side, that will become sine inverse. Therefore, I can say sine inverse of 3x minus 4x cube we had found out is nothing but 3 theta, and theta can be written as sine inverse of x. So this is nothing but 3 sine inverse of x. That will be your answer. Next, let's see another sum, guys. Cos inverse of 3 cos x plus 4 sin x upon 5. Right? Now, this can be written as cos inverse of split the numerator. If I split the numerator, this is 3 upon 5 cos x plus 4 upon 5 sin x. Right? Now, let's see this. Let us assume that 3 upon 5 is, say, cos theta. If 3 upon 5 is cos theta, then I can say therefore theta is cos inverse of 3 by 5. Moreover, if 3 upon 5 is cos theta, if I draw a right angle triangle, 3 upon 5 is cos theta, that means adjacent side will be 3 and hypo will be 5, therefore opposite will be 4. In which case, therefore I can say that sin theta will be nothing but 4 upon 5. From this triangle, sin theta will be 4 upon 5 and tan theta is going to be nothing but 4 upon 3. Now let's continue with our sum. We had cos inverse of 3 upon 5. 3 upon 5 we've assumed as cos theta cos x plus 4 upon 5. We just found out the value. 4 upon 5 is nothing but sin theta sin x. I can use addition formula here. Cos inverse cos A cos B plus sin A sin B is nothing but cos A minus B theta minus x. Right? Cos inverse and cos gets cancelled. Theta, this is equal to theta minus x. Now people see this. We've said that tan theta is 4 upon 3. If tan theta is 4 upon 3, this implies that theta will be equal to tan inverse of 4 by 3. If tan theta is 4 upon 3, then theta will be equal to tan inverse of 4 by 3. So theta I can substitute as tan inverse of 4 by 3 minus x. That will be my answer. Fine. Let's move on to another sum, guys. Tan inverse of root of 1 minus x, 1 plus x plus root of 1 minus x upon root of 1 plus x minus 1 minus x. Right? Now, let's assume let x be equal to cos 2 theta. right? Now before I start with the sum, why did I take cos 2 theta? Because I have multiple formula here which says that 1 plus cos 2 theta is nothing but 2 cos square theta, and 1 minus cos 2 theta is 2 sin square theta. I have it in the form 1 plus x, 1 minus x. So by using the same trigo function, I can substitute both. So let's start with the sum now. Tan inverse of root of 1 plus x plus root of 1 minus x upon root of 1 plus x minus root of 1 minus x. This can be written as tan inverse of root of 1 plus cos 2 theta plus root of 1 minus cos 2 theta. I am substituting the value of x. Root of 1 plus cos 2 theta minus root of 1 minus cos 2 theta. Right? I have already given you the submultiple formula I will be using. Sorry, multiple formula that I will be using. 1 plus cos 2 theta is nothing but 2 cos square theta. 1 minus cos 2 theta is nothing but 2 sin square theta. 2 cos square theta, 2 sin square theta, right? Square and root gets cancelled, so this will be tan inverse of root 2 cos theta minus root 2 sin theta upon root 2 cos theta minus root 2 sin theta. I could take root 2 common in the numerator denominator, so in which case I will get this answer as tan inverse of cos theta minus sin theta upon cos theta plus sin theta, guys. Cos theta plus sin theta minus upon cos theta minus sin theta. Right? Now, I have a tan function outside. I need a tan function inside. How do I get a tan function inside? The first term of the denominator should be 1. How do I make the first term of the denominator 1? By dividing by cos theta. So divide numerator and denominator by cos theta. So if I divide numerator denominator by cos theta, I will get tan inverse of cos theta upon cos theta is 1, sin theta upon cos theta is tan theta, cos theta upon cos theta is 1, sin theta upon cos theta is tan theta. Now guys, see this. The tan theta of the denominator can be written as tan theta into 1. Whether I write tan theta or write that as tan theta into 1, it's the same thing. Now, 1 can be written as tan 45, that's tan pi by 4 plus tan theta upon, I'm not substituting this. This particular one, I'm going to write this as tan pi by 4 tan theta tan inverse. I could use addition formula here. Tan A plus tan B upon 1 minus tan A tan B is tan A plus B, right? Tan inverse and tan gets cancelled, so this will be pi by 4 plus theta. Guys, but x is equal to cos 2 theta. We had assumed this right in the beginning. If I take the cos function on the other side, I will get cos inverse of x is 2 theta. If I take 2 on the other side, I will get 1 upon 2 cos inverse of x is equal to theta. Substitute the value of theta, so this will be pi by 4 plus theta can be written as 1 upon 2 cos inverse of x. So the answer will be pi by 4 plus 1 upon 2 cos inverse of x. This finishes this chapter. We'll stop this here for the day. Thank you very much.